Okay, so guys, we'll be going through this course, this project recursion in C, right? And basically, just go through this resource. Recursion is just about a function calling itself, and they call that kind of function a recursive function, right? Okay, so how to implement recursion, blah 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 blah. Okay, so you should go through the task and the quiz, and then if you go through the quiz, are we in the quiz? Yeah, I think I just closed the quiz. Let me open it. Okay, good. So, what does this code print? Okay, so we have this code, right? This is the main function, okay, and then this is the recursive function, okay. So we are just like creating a function and then calling it, right? So you call this function called print, okay, yeah, right, and you pass 2 as the integer here, right? So you are to expect an output, okay. So this guy would run that 2 for you. So that 2 will be printed, so 2 will be printed. That's why we have 2 here, okay. And then this guy would come, and then let me see, and then it's going to decrement, become 1, okay. And then if this is true, it should execute it. So 1 is greater than 0, right? So it will come into this place, and then it goes back into the uh, recursive statement, right? So 1 is being passed to MB again, so it's going to go back to this place and print 1, right? 1 is decremented um, by this becoming 0. So 0 is greater than 0. Is 0 greater than 0? No. So this will not be executed. So 2 and 1 will be printed. Okay. This second one, the output is not 2, right? I think it's supposed to be 4, 3, 2, 1. So anyway, so you can just go through this one. Okay. All right, what does this code print? Okay, so we have this code over here, and then we are passing 4 to it. Okay, so basically since we pass 4 to this guy, 4 will be printed first, right? So that's why we have 4 here, and then 4 plus plus, meaning that it becomes 5. Is 5 less than 10? Yes. So it will go back here, so it means 5 will be printed, right? So it will become 6. Is 6 less than 10? Yes. 6 will be printed till 9. Okay, and then when it becomes 10, is 10 greater less than 10? No. So this will stop. Okay, so that's it. So what does this code print? We have this guy, and then it says void print int mb blah blah blah. So we have this int, right? So this is the recursive function, this is the main function. We pass 4 into it, and then is 4 less than 0? Right? It is not. So this will not get executed, right? So to come here, it will print what? 4, right? So it will print 4, right? So this guy will print 4, reduce it by 1, becoming 3. It will pass it into this guy again, and then it goes again. He's is what's it called? Is 3, right? Less than 0? No. It will come here again, print 3, reduce 0 by 1, becoming 2. Is so it's 2 less than 0? No. Print this, reduce it, becoming 1. Is 1 less than 0? No. Reduce it, becoming this, right? Reduce it, becoming this one become 1, and then this one becomes 0, right? Is 0 less than 0? No. So 0 will be left out to us to print. Okay, so what does this code print? So this is the fourth one. I think this is the last one. Okay, so for this one, it says, what does this code print? This is the last one. Yes. So we have the main function. 4 is being passed to this main function. Okay, so it's going to first print 4, right? Obviously, right? So we have the 4 printed here. Okay, so it's going to first print 4, and then it's going to reduce it by 1, becoming 3, right? It becomes 3. So is 3 greater than 0? Yes. Then it comes here, passing 3 to this guy, right? And then go here, right? So um that's where the 3 gets printed, okay. And then it decrements by 1, becoming 2. Okay, is 2 greater than 0? Yes. Then 2 is passed to this guy, and then uh, this guy will print 2, 1, and then when it gets to 0, 0 is not this, and then this guy is not going to get executed. Okay, so that's it. So I've done this first task. Okay, so we'll do the second task along, and I will explain this guy to you. Okay, so the first thing you want to do is what I did was I created my main.c. Okay, created my main.c, created my main.h, and then I imputed this prototype into my main.h, right? And then I created a git ignore to ignore the executable file and all my main.h, and also I created a readme file and everything inside this directory, right? So I created that, and then I created this file in which the code we need to submit will be passed on to. Okay, so you just need to submit this guy and the main.h, right? Okay, so the remaining ones are for testing your own so that you can see it before submitting it also. Alright, so zero put recursion.c. So as you can see, I have my readme. I copied my put char from 0x07. Okay, posted it here, created my main.h. This is the main file, this is the executable, and this is the so this is the function, sorry, recursive function. Okay, so let me put this one on silence. All right, good. So that's basically it. All right, so let's vi into the zero put dot c. Okay, so what I did here is I said, okay, we have to have a base, right, in order to not to make our recursion continue overlooping, right? So we have this string s, and then we said if our so I said if this star s is a pointer, right? So I'm dereferencing the pointer to get the character inside. So I'm saying if the character inside is not equal to null, okay? If the character inside is not equal to null, so that's what I'm setting as my stuff, as my boundary, right? As my base, right? So if this guy is not equal to null, you should just print that character, okay? And then it should increase the pointer where that character is being pointed to. Remember that the pointer will only point to the first character of that string, right? So we are increasing the pointer to 1, and then it's going to come back again. So it's going to come back and then do the same thing. So is that place equal to not equal to this? Yes, they need to print it again, increase it like that, like that. So we now, because we want to create a new line, then if this place is now equal to this guy, you should just print a new line. Because if you add new line to this place, it's going to add new line to every character it's printing. Okay, so basically that should be it. Yeah, so if you do that, it's gonna work. So let's go to the next task. Okay, okay, so the second task we have, it says what write a function that prints a string in reverse. So that one will print it forward. So let's try reverse. When I was doing the first one, I actually first did reverse mistakenly. Okay, and then I had to correct it in order to make it print in forward mode. Okay, it's just like the last one I did. Okay, so it's gonna be easy, and let's see. So what am I going to do? Okay, so I copied this guy. Okay, I copied this guy. I pasted it in my main.h. So let's just copy this guy and create our main.c. Okay, so as you can see, it's this Colton Walker is what they passed it, and then it printed it in reverse. Okay, so one main.c. So I will say vi one main.c. Okay, I don't know. Let me know on the comment section if you prefer code along or just explaining the concept, because I've made a code along video, and I've been making explaining concept video separately. So I don't know which one you would prefer, because I think explaining concept is much more faster then code along, right? So with your feedback, I would know what to do with the next video. WQ, yes. So we've created our one main.c, right? So the next thing I'll do is the executable file. I don't want to push it, right? I'll put this one in my git ignore, right? So I'll say vi.gitignore. So I've said my git ignore should not push all anything anything that ends with main.c should not push it. Okay, so I'll do that, and then this is the executable for the first one, this is the executable for the second one. Escape WQ. Okay, so good. And then the next thing I'm gonna do is probably the file name. Okay, copy, and then I'm gonna vi this, right? And I'm going to include main.h. Don't forget you have to put the prototype in main.h. I've already done that already. Okay, all right. Yes, so I need the prototype again to copy it because I'll be using it now. So remember, it's going to return a void, print reverse recursion, blah blah blah, like this. Okay, the stuff is looking like the same thing I did before. Okay, no, not the same thing. All right, so let's see. So I'll do like this. Good, good. So this one will print string reversed, rever, reversed. Okay, so we have a string s, right? Let me just confirm string s, right? Okay, this is the string to be reversed, right? And then we are returning nothing, so we can leave our return to anything, right? We can include it all. Did I do this guy well? All right. So for this one, what we'll do is um, we want to do almost the same thing we did before. Okay, so this one, if I look at it very well, let me see if I'm going to add new line to it. Okay, this is supposed to be a new line, right? I don't know. Let me try it and see. Okay, because if I'm adding new line to it, it would act abnormally. Okay, so I will do my if statement to create my base. That base is very important. You have to create your base, and then I want to stop when it has gotten to the null. Okay, so when that character inside is not equal to null, okay, not equal to null, that is when you should stop this. And that is once it's equal, stop it. As far as it's not equal, do these things. Okay, so that's what I want to do. So the other time I printed that character first, right? I printed the character first. Okay, so I printed the character first, and then before executing the before recalling the function. But in this one, I'm going to call the function first. Underscore print reverse. So in this way, when I'm calling the function first, it's going to make it open the reaction. Okay, pend what it's going to do is going to start from the last thing and then print it downwards. Okay, so that's what I'm going to do. I'm going to pass this one. um, uh, I'm going to say it should pass it s plus 1. Okay, and then I'll explain this to you. Sure. Okay, and then I'll say you should print that character. Okay, so like what I did before, s plus 1 is going to change the pointer to the initial ground, right? It's going to change it and then it's going to print. So this one is holding for the first one upward to the last one. It's going to keep pointing to them. So what recursion does is that it makes it print backward automatically. Okay, it prints backward automatically. So let me just run this guy and see and see recursion GCC. Okay, okay, so I'll do like this and then I didn't even check if it needs bets. Okay, one. Okay, can you see? It's even added the new line for me. Okay, so regular not lock. Okay, regular not lock. So I think we are good like this. So if I git add it, I think I'm safe. And then git commit and then print string reverse push. Sorry, I made an error there. Oh, I didn't put my stuff. Sorry about that. And then git push. Okay, then, so let's check. So that basically what you should do. Recursion is kind of a basic uh, concept that is very hard to grab, but once you grab it, oh, my light is off. Once you grab it, you get used to it. Okay, so I think we are good, right? So this one, it says, let's go to the next one. It says dream feels real. Okay, I don't need to read that one. Write a function that returns the length of a string. So we've been doing length of a string, right? So we want it to return the length of a string. Okay. So string length. We know we've done string length normally. Okay, but now I want to use recursion to do it. Okay. So we'll copy this guy. I don't even need to copy this guy yet, but I'll do ls and then I'll do vi main.h. Right. Okay. I've added it and then escape WQ. Okay, I've added that to main.h. So the next thing I want to do is I want to create this to main.c, right? So to main.c, I'll add this guy to it, and then vi to main.c, right? And then paste this guy. Okay, so the next thing I want to do is what else? Let's see. Okay, so let me add my executable to executable to sorry executable to git now, right? Yes, so the next thing I want to do is create my file, right? My project, so I can just view into it. Okay, yeah, so include main.h, right? And then we'll have our stuff, and then once the copy the prototype again. So string learn recursion, showing that you are using recursion, right? Let me just paste this guy here. So this one is just for pretty sake. It's not part of our code. Okay. Print the string len, len gth gth. Alright, so we'll have our string, right? And then are we returning anything? I can't remember it returning anything, but in case it will, this won't give us issue. Okay, it's going to return an hint technically because at least it's the length that we want to subdue. So number of string or length of string to return length of string as an integer, right? So good. So okay. So this is it. So what are we going to do? We have to create our base and then use our recursion to kind of loop through, okay, loop through and then return the value. Okay, so that's what we want to do. So if would always help us create a base, right? So if that string is not equal to null, as the same thing that we do, is not equal to null, right? Null will be like this, right? Then execute this block of code. Okay, so what are we going to do? You should return, if it is not, you should return 1. I think 1 plus underscore we'll call it string length underscore recursion, and then we'll pass it s plus 1. Yeah, I think we're good like this. If it is equal to that guy, you should just return 0. Okay, so what we are doing here is we are telling you that, okay, that once it is not this guy, right, you remember this guy now is going to keep pointing at the next, at the next, at the next. So when it gets to this place, it's not going to point to it. Okay, so if it is equal to this null, it's just going to return 0, right? So if it is not, it's going to add 1 plus, then it's going to do this one, right? So if it is two string, for example, if it is 2, right, we have 0 and we have 1, right? So it's going to return 1, right, and add it to the next one, which is going to give us 2. Okay, so I don't know if you kind of understand this kind of scenario. So this one is holding down, right? So we are just adding based on how many times this thing can go. Okay, how many times this stuff can go. Okay, so if this thing keeps, if this one still goes 5 times, okay, if it's still 0.5 times, it means we are going to add 5 to this one, right? If not, we're just going to, because for it to enter this loop, it means that there's a probably string inside, right? So even if it is just 0 0, right? So if it is just one thing that is inside, it's just going to print return 1. Okay, if it is 2, it's going to return 1 plus that next one. Okay, so I think with this we should be able to come up with something. So let's just execute and see. Let's compile. Okay, I misspelled something here, right? String length, not string length. Okay, so let me just go into it again. strlen, yes, strlen. So let's recompile. So it worked, and let's see. Two string recursion, so 14. We are good, right? So that's basically it. We have 14 as well. So you can git add. Hey, why do I keep dragging this guy? You can git add git commit -m, and then what is this guy? Print string length len gth with recursive function, right? Okay, I hope I put that guy here. Yes, I did. Git push, and yes. So let's go to the next one and let's do this guy. Okay, check code. Good, yeah, good. So the next one, it said write a function that returns the factorial of a given number. Okay, this one I think is the most used example to explain how recursion work in C. I think almost all videos online would always use this factorial function to explain recursion. But anyway, let's go into it and okay, let's leave this one for later, or let me just copy it now. Main dot h, right? So let me clear vi my main dot h, right? And then I'll paste this guy here. Okay, good. So I'll create my um, factorial is just, if I have 5 factorial, it's just 5 times 4 times 3 times 2 times 1, right? 4 factorial, 4 times 3 times 2 times. So if you are good with math, I think this guy would actually help you. It will help you. Math will help you once you're doing this guy. Okay, 3 main dot c. Okay, good. Right. So I've created these two guys. Which one is next? My executable, add it to my git ignore. This guy. So I'll add it vi. So all this thing, if you push it to your GitHub, you won't be penalized. But just to make your work neat on GitHub, it's better to just do it this way. Okay, so it would be easy for anyone that wants to check your codes and stuff. All right. So the next thing we want to do is, okay, when we execute it, we are supposed to have this, right? So we are going to have, I think that one is for factorial 1, right? Which is 1 times 1. Factorial 5 will give us 120. Factorial 10 will give us this. Factorial minus this will return minus 1. Okay. So in this case, we are having a negative number as well. Okay. So we have to consider this guy. All right, because I think most example doesn't consider negative numbers factorial. All right, so we have to just set a rule for that negative. Okay, so we have two base statements. All right, so we'll set that. So let's int factorial int n. Okay, let me copy this guy. So I'll have my this guy. I can just do like this and first create the file touch so that I can just copy this guy, the prototype. I like copying those stuff a lot because just one single mistake in the spelling can just mess your head up. All right, so I've copied that guy and then let's go back to it. So I will vi into my 3 and then I will include my main.h, right? And then this guy will be out, and then onto this. Okay, and yes, so this one would get the factorial of a number, right? So I think our is n, right? Number of factorial. Let me just put that. Factor to factorialize. Yeah. So it's going to definitely return an integer, right? Factorial factorial of n. So we have that. Yes. All right. So we have this. So we want to create two base statements for when our n is 0, that's when our loop should stop, and also when our n is less than 0, it should return -1. Okay, so we'll just say if our n is equal to 0. Okay, so this is what we want to use to, this is what they use basically, and then they'll say it should return 1, right? So this is what they do, and then they go else, and then if you are doing it normally, and then you say it should return this guy, and you say n, so it's going to return, because factorial is 5. If you're saying 5 factorial, it is 5 times 4 times 3 times 2 times 1. So 5 factorial is also 5 times 4 factorial. So we just say 5 times, so if it is 5, so this one will be 5 and then times 4 factorial. And to do 4 factorial, we just say factorial. 4 factorial is just factorial 4. Right? How are we going to get 4, which is n minus 1, which is 5 minus 1, right? So this will help us solve it, but we need to add condition for negative. Okay, so if this one is, if we don't have negative number, if I compile it, it's going to work, but that negative one will not work, right? So to add that, we just put else if our n is less than 0. Okay, if it is less than 0, then what are we going to do? Then we say that it should return -1, right? And then end. Okay, I think with this we should be good. So basically what this guy does is going to do that reversal printing that I told you, right? So this guy would 5 would be pending here, and then would do for 4, would do for 3, would do for 2, would do for 1, and then 1 will multiply 2. When you get to 0, 0 is 0, it will return 1. Okay, so 0 will return 1. So since 0 is 1, then that 0 has automatically become 1. 1 would return 1 as well. So 1 times 1 times 2 times 3 times 4 times this 5, okay, will give us 120 for that 5 factorial. And then I hope it's kind of hard to get, but with time, I think if you try and check online, try and understand. Probably I'm going to just do a factorial. I say factorial. A Look at my factorial spelling here. What's it called? Escape. Let me just. Okay, I misspelled this guy. But yeah. So a recursion video on its own. Okay. So yeah. So let's compile and see if it works. I think this factorial is like best explanation so far. So I've not even been checking my Betty. Alright, so recursion command not found. Oh, sorry, I'm not supposed to put recursion. Oh, I was wondering. Yeah, so yes, so dash 3. So we have 120. Yes, I think we are good like this. So we clear it, and then git add it, and then we'll say find the factorial of an int, right? Or of, let's use of a number, right? Git push. Okay, so since it has git push, let's check it. My battery is getting low. I hope they bring light before we finish this. Yeah. Okay, good. So the next one we want to do now, how many do we have left? 6, 6, and 7, 8. Okay, still have probably 4 left. Let's open this guy. All right. So let's see where we can stop. So there's light, I'll continue. Once an idea has taken hold of the brain, why do I keep reading all these things? Write a function that returns the value of x raised to the power of y. Okay, x raised to the power of y. Okay, so we are doing this. So before we even start, let's just first set up like we used to do. So I'll copy this guy and then vi main.h, right? Then I'll paste it there. All right, so I'm going to create my for main.c. For main.c, right? Yes. So the executable, I'll post it in my um, git ignore. Good. So let me clear it. I think I'm almost done. Then I'll copy the file name. So basically, 5 raised power minus 2. We have 5 raised minus 5 raised power 3 minus 5 times minus 5 times minus 5, right? 5 raised power 2, 5 times 5. 2 raised power 16, 2 in 16 places, right? 5 raised power minus 2, I think, is 1 over 2, 5, like that, something like that. I think that's why it's giving us minus 1. And then we have, where's it? And we have 1 raised to power 10, 1 times 1 times 1. Anything raised to times 0 is 1, right? This one, anything raised to power 0 is 1, right? So that's why it gave us 1. So anyway, we need the file name for power recursion. So let me vi into it. Okay, so I'll get the name of this guy, right? Power recursion, we have x and y and int. Okay, so sorry. Let me undo that. Okay, good. So we have our include main.h, right? And then we have this, and then I can copy this. All right. So 1, 2, 5, 6, 1, 2, 3, 4. Good. And right. So what we're gonna do next is the power of 2 int of a number of 2 int of a number. All right. So we have x and y. at, where's my at x, that's the number, and then at y, that's the power. It should return it should return the it should return the results of our, so we have our this guy here and then this guy. All right, good. So we have to have our base, and our base is when y equals to 0. Okay, when when y is equals to 0, it should return 1, right? Because anything raised past 0 is 1. And then when it is less than 0, like minus something, it should return minus 1. Okay, so we are going to have that two arguments. Okay, so the next thing is when it is, then we'll now give it our recursion, right? Okay, so what we're going to do, you say if our y, right, is less than 0, it means it is negative, right? So you should what? You should do this. Then our return minus 1. That's what we saw there, right? Okay. Else, if our y is equal to 0, you should what? You should return 1, right? Okay, so we'll now have something that would be adding up all the time before our y get to 0, and then it adds up 1, multiply it by 1 as well. Okay, so what we're going to do is we now say return, right? Then we now put the statement inside this bracket. So it's the statement inside this bracket that is the full recursion. And don't forget, we'll have to do our call our power, right? We first call it because we want to use recursion, right? And then we pass it into this bracket. Okay, so before the power, we want to first get the first number, which is going to be x, right? So it's x that is going multiple times, so x will multiply another number. Which number will it be? It will be x is going to multiply x, okay, comma, and remember this one is x and y, and then our y will decrement by 1. Okay, so with this it should work, right? So um that's what this guy is going to do. So you just need to just go through it, get to understand it more. Okay, because there's a saying that the best teacher cannot teach you everything. You get, like, teaches you probably like 10%. Okay, so you have to know it on your own. So basically, what happens is that this guy is holding the first, if this y minus 1 becomes 0, okay, then it will be 1, so x will just multiply 1. Okay, if y minus 1 is 2, it will come here and say that it is greater, then it will still pend that x, it will add the x to this guy, and then do y minus 1 again. All right, so basically that's how this guy will work, and let us compile to see. So my battery is getting low. I might stop anytime. I've not even gone through this project at all. Just all right. I just hope this thing are meeting Betty standard. 1 1. I think this is exactly what we got. 1 1 6 6 5 25 minus 1 minus 1 to 5. Okay. All right. So why this one is giving us minus 125? This is our y. It's not the one, not it's not the negative number. Okay, this is the only negative number, and it's the one giving us minus 1, right? So basically that's it. All right, so let's git add and git push and see. I don't know why I keep dragging this guy. So we git add, git commit. What's the message again? Find power. Find the power of the number, right? And then we git push. All right, so clear it, and that's it. So let us check. So I think after this one, we're just gonna take a break, and then the next chapter we're gonna do the next one. So how many do we have left? We have number 5, number 6, number 7, number 8. Okay, 5, 6, 7, 8. So we have 4 left. So let's see if I can still do one. All right, so let's just create down this guy, right? So in write a function that return the natural square root of a number. Okay, so if n does not have a natural square root, the function should return minus 1. Did they give us that information here? Oh, if y is less than 0, the function should return minus 1. Okay, they've given us here too, so that's why that one is returning minus 1. So this one is going to have two kind of statements, right? Base statements, right? Okay, and then yeah, it's gonna have two base statements, and then I think we're gonna have two functions here to make it work perfectly. All right, so let's copy this guy. Okay, let's copy this guy and vi into our main, right? Dot h, and then I'll paste it here. All right, escape vq and our main dots 5 main.c, copy the guy to test our work. Copy vi5 main.c. Okay, then what else? 5 main.c. What else do we need? Recursion 5 main.c. The execution executable. Add it to git ignore. Oh, sorry. vi dot git ignore. Okay. Yes. All right, so what else? We have main, we have this, we have this, just our main file, and we're good to go. So this guy, and then I'll come back and copy the. So let us first create this file first. All right, and then the prototype again. Page up. All right, so copy this guy. So I'll go into this guy and vi. All right, so include our main dot h, right? So in this function, okay, let's go through the stuff again. Let me save and quit it, and let's go through it. It said write a function that returns the natural square root of a number. So the square root of a number, if n does not have a natural square root, the function should return minus 1, and then we have the sqrt square root function that does the work. Okay, so we have a number 1, right? So what is the square root of 1? 1 is 1, right? 1024 32 32. Okay, so if like 17 does not have a square root number, I'm very sure. So 17 will return minus 1. This one is 5, right? So do you understand what you want to do now? Okay. And then minus 1 does will be minus 1. Minus 1 is what? No. So it does not have, then it's going to return minus 1. Okay. So basically that's it. All right. Good. So we have that to do. So probably once I'm back, this once I'm back, it's going to be our second half, and then we're going to finish up. All right. So yeah. Bye. Okay, guys. So back to this number 5. I think that's where we stopped before. The light was off, and then the light is back now. So let's just take a look at everything and let's finish up these tasks at once. Okay. So I think we've done some things. CDUX08, I guess. Yeah. Sorry. And then LS. So VI into the 5SQ square root recursion. Okay. So this is where we stopped. All right. Good. So for this one, um, look at it. Say we should write a function that returns the natural square root of a number. That is, if, and I think I explained already. Okay, so yeah, I think I've explained all this. That if like 25 has the natural square root, right? 17 doesn't, right? I guess so. Like that. So all those ones that doesn't, it should return minus 1, right? Minus 1 doesn't. 1 has, because 1 times 1 is still 1, right? So that's what they said. It said if n does not have a natural square root, the function should return minus 1. Okay, so remember that we are passing it the square root number, right? We are going to pass in like 25, but inside this they didn't give us space for us to pass in a another integer in order to be able to find the square root. Okay, so in that sense we're going to create another function inside this function. Okay, so we're going to be creating two functions in one file. Okay, and then probably we're going to add the prototype to the main.h. Okay, so that's what we're going to do. So the first thing I'll do is I'll create a power function. Okay, so I'll create a power function. Okay, so I'll call this one the power, maybe operator. Okay, power or power operator. Yeah, I think power operator is okay. Then I would say it will return the natural square root of, I don't want it to be too long, a number, because if it is too long, Betty will have issue. And then this one I'll pass it probably a root. I can pass a root, it's a root and a number, but for simplicity let me just give it n. So I can change the value of this guy. So n would be the input number. So this one will have our input number. Okay, we have input number n here, right? Input number here n, right? So I can change this guy for this second operator, but for now let's just give it as input number, so it will be easy for us to navigate through. And then let's give another one at c. Should we use c? Let's use c. And then this one we'll call it the iterator. Okay, because we're going to be iterating. All right, and then it's going to return an int. Right, it's going to return the square root or minus 1. So this is the where we are going to define our function. So we'll say it's going to return an int. The name of the function is called power operation. All right, so the name of the function is called power operation, and then we'll pass it like this, and then we'll have this, right? Sorry, I pressed something mistakenly. Why is this thing hanging? Okay. Okay, good. Yeah, something like this. So because we defined c and n and c here, which is an int, we are passing it to int. So int n comma int c. Alright, so we're passing it to, you can just write int, right? But it's better to write it like this. Okay, so we're not going to give it condition for us to get it, and I'm going to explain the condition to you. So we'll have our if statement, okay, and then the block of codes, right? So in this if statement, we want to know, we'll say if this is our iterator, right? So if our iterator c, okay, that is going to be a number, right? C modulus, okay, n divided by c, okay, is okay. Before I do this one, let me define this second function. I think it will make it better, but we are still going to go back to this guy. Okay, so the main function we are going to use. Okay, so I'll just say it's called what is it, underscore sqrt recursion. Okay, underscore sqrt um recursion. Okay, and then I think, okay, this one is, it returns the natural number, turns the natural square root, turns the natural square root of the number. Okay, yeah. So what else? We're gonna have, this one has only one parameter in, which is the input number. Okay, and then it will return a natural square root. Okay, and then, okay, so for this one, that's an int underscore sqrt underscore recursion. I hope I spelled it well, because all this spelling used to give up issue. And then it's going to have int n alone, right? It's not a pointer, right? So we'll have this, and then okay, so we are going to have several arguments here. Hold on a second, guys. Okay, so yes, so we're gonna say it should return, okay, okay, so let's go to this guy again. So we have our power operation, right? So this one is to find the square root, okay, to find the square root. So instead of power operation, let me just call it square root, sqrt square root a, right? Let's change this guy so for simplicity. So this one is just finding the square root. All right. Good. So what I'm going to do, instead of using this format, I will just say if, okay, and I'll say if our C here, right, that is if this C, okay, for simplicity let me turn this one to A and B. Okay, good. All right, good. It's good like this. So I'll say if our B, which is, this is the input number that would be fed into your system, and then you want to know the square root, that the perfect square root for this guy. Okay, if there is a perfect square root for this guy, so we'll say if our B, okay, times B. No, this is the square root. We are looking for the square root, right? So if B times B will give us A, then B times B is a perfect square root, right? Then we say it should return, what did they say we should give it? Return, if n does not have a square root, it should return -1. If it does, what should you return? You should return the square root. Okay, it's going to return square root. Okay, so it should return open bracket B, which is our square root, right? And then we'll end it like that. So this square root function would help us find the square root. Okay, okay, this one will just collect the number, right? This guy is going to be our square root. Okay, so okay, so we have if B times B equals to A, it should return B, right? Good. So go next. Then we'll now say else if B times B, let's say we are looking for square root of 4, which is 2 times 2. If 2 times 2 would be greater than 4, you see, when we've done B that 2 and is greater than 4, then it is not the square root, right? It means then it should return -1, right? Then we say it should return -1, right? Good. Okay, good. So the next one we'll now say is when we now use our recursion, and then we'll now use recursion and say return. So this one is serving as our base argument, right? So this one is now return the square root function A, and I will explain why we're doing this. Okay, and then we'll say A comma B plus 1. Okay, so look at it again. So for this place, what we are just saying that, okay, if B times B is lesser now, right? Because here it is equal to A, right? So if it is still lesser, let's say we are looking for the square root of 9, okay, and then the B we pass to it is 2, okay. So if 2 times 2 is not equal to 9, right? So this one is not equal to this guy. This guy will not get executed, right? If B times B is not greater, is not 2 times 2 is 4. 4 is not greater than 9, right? So 4 is not greater than 9, then this guy will not get executed as well, right? So then it will come here and then it will call itself and says that, okay, we still have 9, okay, and then we now increase our 2 to 3, then it will come again. Is 3 times 3 equals to 9? Yes, then it will return 3. Okay, if it is now 3 times 3, is it greater than 9? Okay, so is it greater than 9? No. So this one it will have done. So if it is like probably 10, okay, is it equal to? No. Is it greater than this? No. Then this one will become 10, and then it's still 10, right? This one will now be 3 plus 1, right? It should be 4. 4 times 4, 16. So it's not 10, and then 16 is already greater than 10, so it will return -1. So I don't know if you understand this. This is quite simple. It's like the simplest way ever. All right. So if you still have issue, let me know in the comment section. So now we are now going to use this square root function to call it, right? To call this guy. So we are going to now pass in an argument for b, and then b would put it to be 2, because 2 to be 0, you should start from 0, right? You should start from 0 because you can't use 2 because 1 times 1, right? So you should start from 0 times 0. 0 times 0 is what? 0. So we are going to give b a 0. So we are going to call this sqrt function and open a bracket, and then we'll give it that 2 arguments. We'll pass it the value of n, right? Not a. It's not okay. So we are passing n to this guy, and then to the second guy we are passing 0. Okay. So I hope this explains it. Yeah, I think we are done. And with this we should be able to do something. So don't forget, let's put this guy in our prototype, in our main.h, right? So I think we've put this guy before. I will check. All right, so let's save and do this, and then vi our main.h. Yes, I've put that guy. Oh, sorry, don't forget to put your semicolon. Enter. I just like arranging it. It's not like if I don't put enter it won't work. All right, so what do we need? We need to compile it. Okay, I've not been checking for Betty and it has been working, so it means we are um, Betty experts now, hopefully. All right. Yay! So many error saying we should put maths.h blah blah blah. All right, this is the fear of every coder. All right, let's go through it and see what we've been doing. It says okay, I didn't put semicolon here. sqrt underscore a is supposed to be here, and what else? Okay, sqrt underscore a. All right, so I think it's my fault. Okay, so let's go back to vi this. Yes, so this guy is supposed to be, I was wondering why it is not, it is not insert underscore a. Yes, and then which other guy is not having, I think we did it right now. Let's check again. Clear. All right. Okay, the error has reduced. So 19, 19, 19, 19, 20. Okay, 19, 19, 20. Let's see. What's that? Cockroach. 19, 19, 20. Sorry, I was distracted. 19. Okay. Return. Okay, 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 okay. Okay, return sqrt. We are passing it a function. It's supposed to have its own braces, right? sqrt this, and let's check again, because most times that guy used to be, yeah, we are done. So let's test. So we're having 1 minus 1 minus 1 minus 1. I think there's an error somewhere, so let's check again. Okay, is equals to a, b times b is greater than a. Why did I put 4 here? This one's supposed to be a. If b times b is greater than this guy, it should return -1, right? And I hope that's it. So let's check again. Compile. execute. Okay, 132 4 minus 1 5 minus 1. Let's see. 132 4 minus 1 5 minus 1. Okay, good. So let me just go through it one more time and explain it for those that still don't get it. So we are creating a recursion, right? And it should make us know the square root of a number. So if you look at what they gave us, okay, it does not, it only have that input. We don't have the square roots to return, right? We don't have the square roots. So in order to do that, we created another one that will have input and square root, okay, and then we declared our function there, and then we said if uh, that square root, okay, we now pass 0 to this guy, we declare this guy to be 0. So if 0 times 0 is not equal to a, then it should increase this to 1, right? So if this one is 5, 0 times 0 is it equal to 5? No. Then to not do this, it will go here. 0 times 0, is it greater than 5? No, right? It will not do this. Then it will come here and recall the function. Okay, so this one will be 5, 0 plus 1. This one increased by 1. Okay, then like that, it's going to till this guy is done, and then this guy calls the function. He calls the function. Okay, when he calls the function, it's past the n and then past that 0 that we initialize it to be. All right, so I think we can git add and git commit. Right, and then we can just say this. I hope I've copied it. All right, and then we can git push, and we can check to see if we are right. All right. Okay, we have some failing, probably Betty. So let's check Betty. All right, Betty 5 sqrt underscore recursion.c. No description found for parameter a and b. Oh my god, I've forgotten sqrt. Okay, all right, I got you. What's that, Betty? Boom, ba 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 ba. ABI. Okay, AB. I've forgotten. We change this guy to AB. Truly. A B. Is that all? Let's check again. Okay, Betty. Let's see. Okay, yeah, I think we're good. So git add, git commit, and then git push. We can add our origin. And yes, so let's recheck and see. All right, be fast, be fast. Okay. Um, This guy is taking some money time, so let's just continue and see. But we should be good. Alright. Alright. Okay. Let me just reload and see if it will work out. Alright. It's still loading. Congratulations. So it worked. Alright, so let's go to the next one. And this one says number 6. It says that we should write a function that will return 1 if the integer is a prime number. Otherwise, if it returns 0, I think this guy would define what prime number is. Let me just open it. Okay, so open Wikipedia and make you understand what prime numbers are. Alright, so okay, I think it will. A prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. Okay, that is, if you multiply two smaller numbers together, it will not give you that number. Okay, so 1 times 5 and 5 times 1. So it can, except one 5 can multiply, 1 can multiply that number, right? And then that's all. And then 5 can multiply 1, but no other small number can multiply itself to give you that number. Okay, so 2 times 3 will not give you 5. So 5 is like a prime number. So if you have 6 for example, 1 times 6 will give you 6. 6 times 1 will give you 6, but 2 times 3 can still give you 6, so that makes it not a prime number. So if you have any lesser number that would multiply itself and give you that number, okay, then that number is not a prime number. Okay, except 1, right? Okay, so 1 and itself are those that can divide it, like 11, like 17. You get all those numbers are prime numbers. Yeah, so let's close this guy. So the function should return 1 if the input is a prime number. So if we put a prime number, it should return 1. Okay, so it should return 1. So 1, they said, is not a prime number, so it's going to return 0. Okay, 1024 is not, 16 is not, 17 yes, 25 is not, because 5 times 5 will give you 25, minus 1 is not. Okay, 113, yes it is, 7919, yes it is, right? So this one is prime number. So you might not be able to quickly get if this guy is prime number, but with your function, it's going to help you know. You just pass it this value, it's going to help you know if it is a prime number. Okay, so that's what we want to do now. All right, so in order to do this, let's do what we do naturally. Copy this, add it to, okay, this thing has hanged though. Let's reload it. Frozen. Okay, network is bad. Network is bad. All right, so in the internet it has disconnected, connecting. This thing has started again. Okay, back. So let's go back to our ALX low level and OX08, right? LS, and then we enter our main.h, right? And then we'll add that guy. Yes. All right. Then we can quit this guy and then create our 6 main.c. Copy this guy up to this point. Paste this guy. Okay, so the next one is put the executable to gitignore. Copy. All right, so come here, paste this guy here, right? All right, right? So what next? Then the file name. 6 is a prime number. Right? Vi this. Yes, okay, I think this is good. Alright, so we're gonna include our main.h, right? So in this one, we want to print a prime number, right? We want to know if the particular number is a prime number. All right. So in order to do that, we are going to do like what we did before, and we created two functions. Okay, because this one too would need an extra one extra um, integer, right? So we have to create that. So I'll just do this, and then like the other one where we did that one. So this one will calculate the prime for us. Okay, so this one will calculate if it's or finds prime if it's a prime. Then we have an entry, probably a and b, right? At a, and then we'll call this one the input, and then at b, second, what's, let's just say divisor. Okay, so it's going to return 0 because it's returning an int, right? And then I think that's all. Okay, so it's going to be an int. We call it prime underscore a, and it's going to collect two ints, right? So int a and comma int b, right? And then at the end, sorry, at the end, we're going to have this, right? Good. So what we're going to do now is we are going to give it so many arguments. Remember that a prime number, one, we don't need one to be able to multiply, to divide it, right? So 1 times that number, and that itself times 1, right? So we don't need one, so we have to start from 2 upward, right? Okay, so that divisor is what we need this b to be. Okay, so we'll now do our if statement. All right, and say that if our a, which is going to be the value, is less than or equal to 1, we want to first set that it means that it is not a prime number, right? Okay, or there's our or open brackets, right? Our a is not equal to b. Okay, so we are saying that if um, our a is 5, right, and is not equal to 5, because we don't want 5 to be able to divide it, right? So we are saying we are setting that apart as well, right? Okay, so if this one is not, is going to check if this one is there or this one, and then this one we want to add, and that's why it is in brackets. Okay, and our a modulus b is equal to 0. That is, if we do 5 divided by whatever this guy is. Why is this guy not pressing? I think it has frozen. Is equal to 0. I don't know, the network has frozen. Let me just copy this guy because it might just not work again. Alright, I've copied it. It might just not work again. I don't know what's wrong. Let me just reload it. That's frozen. Alright. I don't know why this nonsense network does this. So the thing is, it's going to create a a file like that will not make it open. So we have to remove that file, this guy, right? So we remove .6, right? And then we open 6. 6 is a prime. So 6, it hasn't saved before, so is underscore 23. 6 is prime underscore number dot c. Okay, so we'll paste this guy inside. Yes, so let me put this guy up. All right, so let me save it first and reopen it. All right, so good. So we are saying that if, where is it? Okay, so it's not 0 like I was saying. So we are saying that if this guy is 1 or less than this, okay, so let me first finish up and then see. All right, you should return 0, right? Okay, so if this guy is going to compare between this guy and the whole of this thing, because and is, the both have to be true. Okay, so it's going to compare, is it less than 1, is it 1, then return 0. Okay, good. So it's going to come here again. It's going to check this guy. If it is not less than 1 and it's not 1, it's going to see if this one is true, and then it's going to return 0. So this one now, we are saying that if a is not equal to b, so if a is equal to b, for example, if this one is 5 and our divisor is 5, so we are not, this guy is not true. Okay, so we are checking if a is not equal to b, and if a modulus b, that is, if you divide, it means that b cannot, if this guy cannot divide this guy to be equal to 0, that is, the remainder will not be 0. For example, if a modulus b, that is, if this one is 10 and this one is 2, right, it means it is 0, right? The modulus is 0. Okay, so if the modulus would give you 0, then you should just do this. Okay, if a is not b, and then a modulus b equals 0, so it's going to check this too. Okay, that is, if a, which is 10, is not b. Okay, if 10 is not 10, right? If you are not using 10, if 10, this guy is not this guy, so this one is true, right? So if this one is 10, this one is 2, for example. Okay, and then 10 modulus b, 10 modulus 2 is 0, so this guy is false. Okay, so it will not execute it. But if it is 2, for example, 10 modulus 2 equals to this, then it will execute and return 0. Okay, so that's what this function work for. And then we have another statement, another if statement, and then we'll say else if. Okay, so we'll say that if our a is equal to b, okay, our a is equal to b, okay, then it is a prime number. Okay, return 1. Okay, so what we are telling it, we are going to pass b to be 2. Okay, so if this 2 is 2, then it should say it is a prime number. Okay, so the next one, which will now be the last one, if not, then it should return, this is what we now call the recursion, right? So it should return prime a. All right, and then you should put a down, and then you should increment b, just like the one we did before. b plus 1. All right, so b will start from 2 and then it will continue, then 3, right? So if a cannot, if 3 cannot divide this guy, okay, it will not execute it. But if 3 divide it, okay, then it is not a prime number. We don't want those 2, 3, 4 to divide that number. You should not be able to divide it. That will make it a prime number. A prime number is one which it can divide itself and only one can divide it. So now we want to use 2 and other numbers. Okay, so if we are dividing it and until it gets to itself, okay, it's only one and itself. So when it gets to itself, it should return 1 because it is prime already. That is what can divide itself. Okay, yeah, so that is it. I think we are done with this function. They will now come to the main function they gave us, right? So I'll just do this. I'll say is, I think is prime number, and this one will say, this one will detect if it's a prime number, right? And then we'll give this one at n the input number, okay, and then it should return, what? It should return 0 or 1 depending on the stuff, right? So we'll declare it, so it's an int. All these things I'm saying is from here, right? So let me just copy this guy. 1 2 3 4, right? Okay, so I can say return, and then I'll call that guy. I'll call it and say prime a, right? I'll pass in n, comma, and I'll pass it that b to be 2. Okay, so this is what I'm going to say. So basically this is it. Okay, this guy will just call this guy and then give b to be 2. Okay, so what we're doing now is saying if, I don't know, I'm just trying to go through it again. So if it is less than, because that's what we have here, those less than and equal to 1, they return 0, right? So if it is less than or equal to 1, it should be 0. If this guy, the b, can divide a, it should still be 0. So as long as b is not equal to a as well, it should still be 0. Okay, so once b is equal to a, it will have passed through all this battle before it gets here. So if b equals to a, then it should return 1. If not, if it didn't meet all this guy, then it should just append that and increase b. Okay, and that's it. So there's, hey, before I do this, let me copy this guy because I have to put it in the prototype. Okay, good. All right, vi main dot h, and then I'll put this guy and this wq. Good. So I think we can test. Let's test. I'm going to bet it this time around because I don't want that guy to bring us back. Betty sees dash is, this thing has frozen again. Thank God we are done. Okay, so let's see. Okay, so we have some Betty errors anyway. Please, no spaces at the start of a line. 10, 10, 16. Okay. Parentheses are required on a return statement. Okay. 10, 10, 16. So let's go back into it. And then we'll set number 10, 10, 16. Okay. So 10, 10, 16. What is that error of 10? 16. Okay, we are supposed to put comma to this guy in this 16. Okay, on 10, let me see. What's going on with 10? I don't know. Let's try again. Clear Betty. Okay, 10, 10. Code indent should be tabs where possible. Okay, and then no spaces at the start of the line. Okay, okay. Let's try and fix that. Is there space here? No space. Okay. So I'm trying to delete these spaces. I think I've over deleted it. Alright. So let's try again. Betty. Okay, we are good now. Alright. So let's compile. Did I copy the compilation? Alright. Okay, it compiled and let's see. 0001 0011. Let's see. Okay, I think we are good. So we can git add now and then git commit and then we'll check a function that returns blah blah blah. And then we can paste this guy and then we can push. Okay, so let's check our code and see if it's working fine. Check code, working fine. Okay, so good. So we have two left. All right. So for this one, we have our first one, which is 100, and this one says we only have a function that returns one if a string is a palindrome. Palindrome are just words in which if you spell them forward and backward, they are the same thing. For example, if you have the word, let me clear this place. So if you look at this, A, B, C, B, A. If you look at it from here, A, B, C, B, A. So this is a palindrome. They are words that which you spell them forward, you spell them backward, they still are the same. Okay, so that is what it is. All right. So we'll do ls. Let me clear. And if you look at the question, they said if it is an empty string, you should still see it as palindrome because at least it means if you are spelling it backward and forward, it's still going to give you the same thing. All right. So so let's just create our 100 main.c for testing. Copy. All right. Created that one. The next one is um, let's quit this file. Let's just create it down. Alright, then let's go into our git ignore to put our executable. I think this is our executable file name. Alright, so the next thing is I've done this, the main.h. Right, so add this guy. So for this guy, we'll have up to 3 functions, and I'll explain why. So one of the functions we are going to create is a string length, okay, and we're going to use recursion to create string length, okay. I think we did that already in our first task also. All right, so we use recursion to create string length, okay, and then we'll create some other functions, one more other function, and then the real function. And this is because of that still same limitation, okay. So let us vi into our 100 is this dot c. So I'm going to include our main.h, right, and then I'm going to do like this. Okay, I think this one has frozen as well. Okay, the network is acting up seriously. Alright, that's frozen. Let me just reload it. So I have to delete these the temporary files I'm going to create. Alright. Wow, I've pressed so many things and it's not working. What the fuck is going on? Oh, it's working now, and I've reloaded it. I wasn't looking at the screen. So it's going to create this guy. So I want to remove that guy. This thing is freezing. I might need to stop and continue again. Anyway, is it 100s or 100 is? Yeah. So this thing is freezing. I have to be fast. I'm trying to be fast. Let me save this guy first. Reopen it. I'll save it. I've reopened it. And then that's to have two here. Betty style. Okay, so we're going to first create our string length. Okay, so I will explain why we're creating it. Okay, basically, if you have a word like that, it said write a function that will return one if it we want to check if it is a palindrome. Okay, if it is same spelled forward and backward, right? And to check, we have to be comparing the first and the last together like that in order to know, and we have to get the string length in order to say, okay, once we get the string length, then if the string length is 8, then we'll say compare number 1 and number 8, compare number 2 and number 7, compare number 3 and number 6, like that. Okay, so that's what we want to do. So to get the string length, then we'll do this one, and then we'll call it underscore string length, then underscore recursion. Okay, this one is to get, hey, why is this thing hanging now? I need to be doing these things offline to make it work. To get the string. And why I haven't been using vagrant is because the color of vagrant is kind of blue and it blends with this background, so it doesn't work well. Okay, so I've been trying to edit the color, but it's a long process. All right, so to get the string length, right, and then we are going to pass it just the string, right? So the string is s, I guess, and then this one will be string, and then are we going to return? Yes, we should return the length of the string, right? And then it's going to be int because we're returning it, and then the name of the function string str, let me misspell this time around, recursion. Okay, strlen recursion, and then it's going to take in a character, a pointer to it. Okay, this pointer um, is to the string, right? And then we'll have this, and then to do our string form, let me see. Okay, enter. Okay, good. To do that, we'll just say if, to create the base, right? So if we are dereferencing our string at that first index, right? So this one is string at index 0, right? If this guy is, once our string is equal to the null, we should stop, right? So we have to do this stop, right? We should stop. Okay, and then it should, at that point it should just return 0. Okay, good. So else, what should it do? It should call itself and return. It should return, all right. So it should return, else it should return 1. In case it is more than one string, then it's going to recall this function. Okay, and then it's going to say plus, right, because we want to get the string length. Okay, and then we say the string length underscore recursion. Okay, pass it an argument, and we say s plus 1. Okay, so the s will now move to the next place, right? If the next place is not null, then it will add 1 to it, right? And then still go back again like that, and then this one keeps increasing. Okay, so that's what it does, and then I think we're done with that one. Good. So the next, let me save this guy because I don't trust this stuff. Let me reopen it. All right, good. So the next thing we're going to do is we're going to compare the strings, right? I want to compare if the first is equal to the second, like that. Okay, so we are going to do int. Oh, I have to give it all the logo, the description. Okay, so let me just call this one compare, right? Compare underscore compare string. Okay, okay, and then this one I'll call it, we'll compare each character of the string, right? And then this one will have 3 things. It's going to have the string, and then at instance left and instance right. Okay, so we're going to have this, if this is the string we want to compare, we check for this guy and this guy, right? So we give those guys value and name as well. So we'll have our s, which will be the string, right? And then we can have at instant left, right, left, which will be the smallest iterator, and then at right, which will be the largest or largest iterator, right? And then we're going to return what's it called, the pali, if it is true, an int. Let me just put an int. Alright, so let me save this guy and reopen it again. Alright, so for this one we're going to have an int, and then we'll call this one compare string, right? Compare string, and then we open the braces, and then this, right? So what we're gonna do to this guy is that we say, and note that this is not the only method to solve this question. There are always millions of methods. Okay, so we are going to pass in this guy. It's a character s. So I've already passed it. I don't know why it's not pressing, but thank God I saved to that point. I think we are back to trenches. It's not working anymore. Did it just work? Okay, character, and then pointer to s. Okay, let me just quickly save it and reopen it. Okay, pointer to s, and then we'll have the next one. We'll have the left, right, int left, and then int right. Right, good. I said right. All right, so we'll say if now, right, our base, if the character at s plus left, so if our left is 0, this one will be like 7, right? Okay, so if our character at plus 0, which is at index 0, okay, if our character at index 0 is equal to our character at index right, okay, so these ones, let me just put them in brackets. All right, then if it is, then it should do this following block of code. Okay, and then it should, if it is not, it should just return 0, right? Let me first save this guy and reopen it. I've saved it. I'm trying to reopen. Good. All right, so what block of code are we now giving it? Okay, so we are trying to compare them, right? Okay, if it is like this, then we will say, okay, then if again our left is equal to our right, okay, or our left is equal to our right plus 1. So what we are saying is Okay, so you said this, right? And we said that if left is right as well, and or left, this guy is equal to right plus 1. That is, if it is if this guy is present to where it is, and then right, remember that right will not have the null, so we are adding null. So if this guy is a null, if right is null and left is null, right, we still want to return 1, right? So we are declaring for null. Okay, so that's what we're doing. Then we should return 1. Okay, good. If not, we should just return and then we'll do our recursion. Okay, so we want to now keep increasing left and right. So number 2 and number, if it is 7, number 6, number 3 and number 5, number 4 and number 4. Okay, so we will then say add it with 0, and then we'll call it compare underscore string, and then it will have its own. This one should have a comma here. Okay, so then we'll add 0 plus, so this one should be, because it is still not sure, so it's going to still be return 0 plus. Let's see if this one would make us get 1. Okay, so at the end, if this one will let us fall inside this place, then it will return 1, right? So we'll just say compare fall inside this place. I don't know if you can see it, because I remember that my cursor doesn't work on terminal. All right, so compare string. So we'll say if s comma this guy, right, we'll put the s, and then we'll say our left plus 1, hey, this thing was on, and then we'll say our right minus 1, because we are increasing left, we are decreasing minus. Okay, so that's what I want to do. Okay, this thing has frozen, so I don't know, I think I'll just copy everything, and this guy is not going up. Let me just copy this guy here. I don't know, it's okay, it worked now. All right, so left, this thing is frozen. Okay, plus 1 comma, and then right minus 1. Okay, so we are done with this. All right, so we will now go into the main function and call this guy, right? So yeah, what we did here is that we find the string length, right? Yeah, we found the string length. Let me see. Yes, okay, so in this function we now need to declare what, s is permanent, what left is and what right is, and we'll do that using this guy over here, right? So we'll come here, and then we would write our comments, and then I think is underscore palindrome, right? Palindrome. Okay, and then this one will detect if a string is a palindrome, right? And then we're going to just have an s here, right? This should be the string to test, and then it's going to return, right? It's going to return one if it is a palindrome, comma 0 if not. Alright, so let's copy this guy over here and paste it. Sorry. Alright, good. So what we're going to do next is we'll say if we want to create our base, right? If that string is equal to null, that is an empty string, right? Remember that they said empty string should still return 1. It should return 1. Okay. Alright. So we are supposed to create if it doesn't exist though, but at least it exists. So then we'll now do the give this guy parameter and call this guy, right? Then we'll say return and then do this. Okay, we're almost done. And then compare string, compare underscore string, right? And this one will have its own brackets, right? And then compare string will pass in s, will pass in is 0 will be the first right and left, right? It's going to be left, but right will now be string length minus 1, right? So that's why we need that string length function. So it will now be calling this guy string length recursion. Okay, so it will now be string underscore, oh sorry, I think it's strlen underscore recursion. With this stuff you might just do so many and we'll pass it its own and say it is I think we pass it s and then we minus 1, that's minusing the null character from it, right? Okay, so this s, I don't know, yes, let's just try it. If I'm thinking we should put it in brackets, but let's just try it. And then before that we need to copy this guy's out. Let me copy this guy, then I'll copy that guy later. Okay, and then copy. Alright, so let's save this guy and then ls. So let me bet this 100 is, and let's see first. You're supposed to have, oh, we didn't have any error, that's great. Okay, so what we want to do, vi our main, and then I want to add this guy to it, right? And then I'll put this one in comma, and then I want to add the second one to it as well. So before that I can just clear my screen. I can say cat 100 is, and then pass it to head, so I'll see it, and then this is it. So I used redirection there, copy, so I can just vi into our main.h, right? Alright, it's loading. Good. I'll pass this guy here, that is recursion 1, right? And then good, so we can then let's troubleshoot. So let's copy this guy and compile. This is a word pedantic where extra std okay, so this one we misspelled it, underscore strl string length, right? Underscore strl. So let's go back to it. So our string length is underscore, right? So we'll go here, we only set let's try then if I put my underscore. Alright, so let me clear it and then let's try it. I just cleared. Oh, sorry. Alright, let's try and then // 100 palindrome. We have 1111. Okay, so 1 1. This one is still 0. Alright, so let's try what I said we want to try before. Put that s in brackets and let me try it. This one be 2. Okay, so string length. Oh, sorry. So the string length will pass its s and then -1 outside like this. I think this might be the problem. So let's recompile and re-execute. Why is this not freezing again? Or has it gone to infinite loop? Oh, this thing has frozen again. Oh. Or the data or something. Okay, so it is working now. Alright, so let me go back. So I think we can git add it now and git commit. Alright, so what is it? Sorry. Git push. Alright, so let's check if our code is accepted by Alex. I will go to the last one. Okay, good. Praise God. Hallelujah. Alright, the last but not the least is this one, and it says write a function that compares two strings and return 1 if the string can be considered identical. Otherwise, return 0. Okay, so this one is now comparing two strings, and we've been doing that lately. There are several ways to do this, but I'm just going to use a way of using just one recursion to solve this problem. So look at it now. It is similar to what we do normally. It says that s2, which is second string, can contain a special character. Okay, means s1 will not contain, but s2 will contain, right? And then the special character can replace any string. Okay, all right. So just like we see, main.c, um, it means anything that ends with .c, right? So this one and this one, they are the same thing. All right, so that star, so once it's the same, it should return 1. Once it's not the same, it should return 0. So if you look at it, it's the same. Look at this one. Okay, it's saying that it's going to end with .c. Okay, um, and then main.c, this is the same thing. Main.c, same thing, right? And then we have main.c. This one is just saying that star is going to start with NA and then star is going to end with C. That's why it's the same. This one main, this one is the same. So this guy is saying that there's something here, there's something here. All right. So the one that is not the same, if you count 1, 2, 3, 4, 5, 6, 7, 8, number 8, 9, 10, 11, 12, and 11, 12, right? 8, 11, 12. So we have 1, 2, 3, 4, 5, 6, 7, 8 this guy. Okay, so this one is saying that it end with C, which is correct, and then it starts with, this one should be correct now, right? Okay, I think it's saying that it starts with m dot, right? Which is n dot, not m dot, so it's not really correct. So this one, it ends with C, it starts with some character, it's correct. This one, um it ends with C, it's main dot C. Okay, this one is saying main dot C, but it's not carrying for this extra one, so this one will be wrong. And then main dot, this one is main and this one is wrong. ABCD, this one is wrong, so I think this one is right. These two are wrong. Okay, these two are wrong. This one should be right because we have dot C and this one saying that it contains some other things here. Okay, and iron is correct. Alright, so this is what this guy wants to do, and then we want to print out this guy. Alright, so in order to do this, let's just dive into it. Let's first copy this main.c 101 main.c. Okay, so copy it up to this place. I just pray this thing doesn't hang. We're almost done. We should just finish up with this guy and then we'll rest. So this guy, and then what else? Then we'll get the file name. What is the execution name? 101 wild. Okay, good. So we just create the file name, touch this guy. I don't know why it's hanging. Anyway, vi.get now. Still hanging. Alright, good. And then we'll remove this guy. Alright, so the next thing we want to do is main.h, and then we're going to copy this prototype. Alright, so copy this guy, copy, dg copy, copy, and then we'll go into the file. Okay, then we'll veer into it, then we include our main.h, we'll tag it, give it a name. The name is, I think, Wildcard, wild cmp, wild cmp, wild cmp. Okay, that's wild compare. This one compare to strings. So we have our first string, which is string 1, s1, right? This one is string 1, and then we have our second string, s2. This one is string 2, and then it's going to return, right? And then our string 2, we can just add that can contain this, right? And then it's going to return 1 if identical identity and 0 if not, right? Full stop. Okay, so I think we're done. And then put the prototype. Let me save it and reopen it. Good. Okay, so we're going to have at the end, we're going to have some conditions, and at the end it should return 0 if it doesn't meet those conditions. right? All right. Okay, so the first one we can have 4 if statements. Okay, so we're gonna have 4 if statements, and then we'll say the first one: if our content of string 2, so our emphasis will be on string 2. If string 2 is equal to the wildcard, right? Okay, so if it is this and string 2, the content of string 2 plus 1, that's if this one is wildcard and then the next content, right, is not equal to a is not equal to a null, that is, it means that it is still longer, it's not only star. So at that point we are checking for this guy, sorry, we're checking for this guy over here. No, we are not checking for this guy here. Okay, we are checking for this guy over here. Okay, that the first one is this, and then the next one is not null yet, it is still a character. Okay, so if it is still this, okay, and also if s1, I want to compare now, s1 is still not null yet, is equal to null, sorry, is equal to null, then you should return 0. Why? I'll tell you. So what we are saying here is that if this guy is this and then this one is already null, that is, this one has wildcard and it still have something here, okay, and then this one does not have anything. I don't think we have any case like that. Yeah, I'm not sure. Okay, so if that's it, it should just return 0. Okay, that is not the same. Okay, so we'll have the second statement. All right, so for this one we'll say that if our first string, okay, is equal to null already, is equal to null already, and our second string, okay, is equal to null as well, that is, if they are both empty, it should return 1, right? So we have another if statement. Oh, sorry. So this time we'll say if our s1 is equal to our s2, okay, it should return 1, but we want it, this one will only compare at the first iteration, so we want it to keep comparing throughout, right? Okay, so for that one we'll just say it should return, then we'll have our recursion, return wild, sorry, should return wild cmp, wild compare, open parenthesis, and then it should return our s1, comma, and then s2, s1 plus 1, yeah, it should be s1 plus 1, s1 plus 1, comma, and s2 plus minus 1, right? Let me see, s1 plus 1, compare this one, and s2 plus 1, yeah, plus 1, because it's not the same string, it's different string. All right, so that's what we're gonna do. So this one will keep looping through. Then we'll have the last condition. Okay, so this one will keep looking through until it finds out that it is either 0 or 1, right? And then we'll have our last one and say if our s2, that's the content, is equal to wildcard. Okay, then we'll say it should return, then we'll have our recursion here as well. It should return wild cmp. Okay, and it should return, so if this one is star, right, if s2 is star, it should return s1. Okay, so s1 is still the same thing, and s2 plus 1. So what we are doing here is that we are saying that it should return this guy s1 and should compare with s2. If it is just star, right, we want to compare this guy with the next thing of this guy. So we want to compare this guy with the next of this guy, right? But that's enough will not do. Okay, or we will call the function again, wild cmp. You should return s1 plus 1 comma s2. Okay, so what we are doing in here is that we are checking for this guy, right, with this one. But if it doesn't match, then it should check for that guy and this next one. Okay, so that's what we are checking. And I think with that we should be done. Okay, so we'll Betty 101. Okay, let's compile and see. Have we not created a 101? Oh, I called it 101 main.c. So we'll just rename it to 101 main.c. Alright, so let's recompile. Okay, so we have some error. So let me recompile and see it very well. So you said this or that we have. Okay, I'm supposed to put this guy in brackets. I didn't close the bracket here. Alright, so let's try that first. Okay. Why is this one red? Okay, I think the bracket I put it in outside. I put it there, but it's outside. Okay, I think it's good now. Alright. Okay, it worked now. Then it is 101. So I think we are good. So let's git add, git commit messages, function that does all this. Sorry. Alright. push. Yeah, and let's check. So yeah, it is. So at the end, I think this should work. Okay, I think, and then we are done. So see you. I'm going to try and create OXO7 and hopefully the next topic. So see you. And please try and understand, okay? Bye. Ask questions as well.